Hope you're well and healthy. This is going to be broken up into two pieces. This is about writing ionic equations. So we had last gone through different types of chemical reactions, and we got to double replacements. And with double replacements, it was how do we determine if a double replacement takes place? That's what this is. This is a very complicated topic. Students have a lot of trouble with it, so it's really important that you spend a lot of time with this material and go over the PowerPoints and the examples. The end of the beginning of experiment 8 in your lab manual does a really nice job with this. Your textbook also, chapter 7, section 7.6, from then on to the end and starting on page 220, does a very nice job as well. So like I said, I'm going to break this into two parts. The first part is going to be how to do this, and then the second part is going to be several examples. All right, so this is what writing ionic equations are. How do we know if double replacements actually take place? And so double replacements are typically reactions of ionic compounds. And they're typically ionic compounds in water. So how do ionic compounds behave in water? If an ionic compound is soluble, it'll break up into ions. If not, if it's insoluble, it can form a solid. Now ions can also combine to form covalent compounds. So for example, this reaction, an H+ ion from an acid, a hydroxide ion, can form water. Remember also acids are ionic compounds where we treat hydrogen as the metal. All right, so how do we know if it reacts? The bottom line is if the ions are removed from the solution, then something reacts. Now how can they be removed from the solution? Well, if they form an insoluble compound, those ions are no longer floating about. They form a covalent compound. All right, so the next few slides will illustrate it just looking at this particular reaction. And remember, aqueous means it's soluble. And we'll deal with how do we know if it's soluble. So again, if you take potassium iodide, Ki, and lead-2 nitrate, PbNO3, okay, since they are aqueous, these will dissolve in water, and so the potassium iodide breaks up into potassium ions and iodide ions. The lead-2 nitrate does the same thing, lead ions, nitrate ions. Right? So they break up into ions. When you mix them together, the ions are floating about, and any positive ion could combine with any negative ion. But if the potassium combined with the iodide, that wouldn't be a reaction. And we did that in the last set of slides when we showed how to predict what the products were. The only thing that would be a reaction would be if the potassium goes with the nitrate and the lead goes with the iodide. Now, potassium nitrate, KNO3, is soluble, but lead iodide, lead-2 iodide, is insoluble. So what will happen is the potassium ions and the nitrate ions will still float around, but the lead iodide will form a solid. And if you remember when we looked at this, it's bright yellow. That's just a gee whiz. So how do we figure it out? All right, how do we know what's going to happen? When you're going through the video, especially the next video, hit the pause button a lot and try things on your own. Also, as you're going through the slides on your own, right? Just go back and forth and play with it a little bit. Try things. Don't go to the next slide until you try it. To make it easier for you, things you should have with you. The nomenclature piece is still a big deal, right? So if you're still having trouble with nomenclature, right? So the first flow chart from nomenclature would be helpful. Polyatomic ions, periodic table, okay? Solubility rules, and there's an ionic equations flow chart. These things are all on the website. They're all in this module. So you can make those available to yourself. Pull them up on your screen, print them, whatever works. All right, so a couple definitions. A molecular equation is just the balanced equation, what we've done before. A total ionic equation is a chemical equation showing things as they're actually present in solution. And a net ionic equation is showing only the things that change. Right, so these are the steps, and they're not going to make any sense until we go through them, some examples, but I'll just go through the steps and then we'll walk through at least 4 examples. All right, so write the balanced equation, right? We know how to do that, and you might want to review the slides on types of equations. Then we have to determine what the types of substances are. There are basically 5 types of substances. There's soluble ionic, insoluble ionic, and that's where we'll use the solubility rules that I'm going to go over. There's covalent, and then strong and weak acids, and we'll talk about those as well. Then what we do, write the total ionic equation. We break soluble ionic substances and strong acids into ions. Again, we're writing things as they actually exist in water. Soluble ionic substances, strong acids exist as ions. A spectator ion is anything that doesn't change. It's kind of like canceling out, if you have 2x plus 2 equals 3y plus 2, you can cancel out the 2, right? And then we just clean it up. The net ionic equation is clean up. Let's use the helicopter. If you like it in flowchart form, this flowchart is also on the website, and so you can look at it this way as well. For various reasons, I couldn't put these on the PowerPoint. All right. There's a nice video of solubility rules in this module, right? But just to go through this, these are the general rules. And if you have two conflicting rules, if you have any rule that says it's soluble, it's soluble. So all nitrates and acetates are soluble. Compounds, so any compound with a nitrate, iron 3 nitrate, silver nitrate, is all soluble. Silver acetate is slightly soluble. Slightly soluble in the purposes of ionic equations is insoluble. Compounds containing alkali metals, okay, are always soluble. Ammonium compounds are always soluble. Halides, so that's ions from the halogens, chlorine, bromine, iodine, are soluble except with silver, lead, and mercury. Sulfates are soluble except with silver, lead, mercury, calcium, barium, and strontium. And then these are all insoluble except for a couple exceptions. And I'll show you how to use them in the examples. For the acids, there are 6 strong acids, and these are them: nitric, sulfuric, perchloric, hydrochloric, hydrobromic, and hydroiodic. Again, as we go through this, have these things available to you. Have the solubility rules out. They're available in the module, the ionic equations flowchart, and the strong acids. Maybe write those down on a piece of paper. All right, this is where we're going to stop this set of slides.